And welcome to another video from Way Happy Studios. This is Mr. Meyer, and we are going to talk law of cosines, the final section of chapter 5. And so let's talk about it. We have the law of sines that can take care of all non-right triangles for us, except for two cases, when you have side, 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 or side, angle, side. Right? Those two cases, the law of sines don't work because you don't have your magic pair. And so you need another one. And guess what? If there's a law of sines, there's a law of cosines. I bet you're not surprised. And the law of cosines, to memorize that one is really not so tricky. You might see on the screen there, a squared equals b squared plus c squared minus 2bc cosine a. Just recognize the pattern more than anything else. Notice this looks right here a whole lot, look a whole lot like the Pythagorean theorem. But then notice what I scribbled out. It was 2 minus bc, which happened to be the 2 that were on this side, and then times cosine the angle that was on the other side. And so if you can remember that little pattern, you can remember the formula all the time. Because what I mean by that is if you look in the book, they're going to have an a squared formula, and then guess what? They're going to have another formula for b squared equals a squared plus c squared minus 2ac cosine of b. But I don't have that memorized. I have the pattern memorized again, right? And there's a c squared formula, and guess what that is, right? That's c squared equals, now a squared plus b squared. Now let's use those two sides again, minus 2ab, and then cosine of the angle on the other side, so c. Or just to be silly, you could do anything. You could pick little j squared for my daughter equals my other daughter, Lauren, l squared plus my wife is Rochelle. So r squared minus 2lr cosine of big J. So I can pick really anything I want as long as I know that formula or that pattern for that formula. So let's go ahead and try to use the law of cosines. Now remember, we've got to have two sides. It's got to be side, angle, side, or side, side, side. And probably the most important thing ever in the history of law of cosines. Once you start with the law of cosines, you should finish the entire problem with the law of cosines. You will be tempted to jump to the law of sines, but don't, because of the ambiguous case. Sometimes that can scare you. So stick with the law of cosines throughout that entire process. And now let's go ahead and solve this following triangle. So again, like every other problem that you give me, I am going to draw a picture. So I will draw a picture, and I will call this A, B, and C, and I'm probably sure it's not to scale, but it's just to give me some labels. I know that A is 50 degrees. I know that little b is 17, and I know that little c is 6.2. And I right away notice, uh-oh, I can't do the law of sines. There's no way that I can get a magic pair out of this. So I go to law of cosines, and the one I want to find is little a. So I will use the formula a squared equals b squared plus c squared minus 2bc cosine of angle A. Now the big trick, by the way, that you always remember on this formula is that this is all multiplied together, so you can't just do like this part if you wanted to, because those are going to be all nice numbers. That cosine is going to hold it together. A lot of kids make that mistake, so be super careful. A squared equals b squared 17 squared plus 6.2 squared minus 2 times 17 times 6.2 cosine of the angle between them, 50 degrees. Golden. Look at that. It's all on one side. I'm going to grab my calculator, and I'm going to spit out that final answer for you. So my calculator should still be in degrees, and I'm just going to type in 17 squared plus 6.2 squared minus 2 times 17 times 6.2 cosine of 50, and I get that. And some kids will go like, yeah, I found it's 191, but remember that's a squared, so I'm going to square root that bad boy and get 13.85. So little a is 13.85, but we are not done. That is just this side. Right? This is 13.85. We still do not know one of the angles, but now we have all the sides, so you pick your favorite angle. I think my favorite angle will be B. Usually I go after the biggest one, to be honest. B should be the biggest angle in this triangle, and so I'm going to go after whichever one's bigger. So I will go after b. So that means that I'm going to do b squared equals a squared plus c squared minus 2ac cosine of angle b. And so for me, that is going to be 17 squared equals 13.85 squared plus 6.2 squared minus 2 times 13.85 times 6.2 cosine of whatever the heck b is. Now here's where I have to warn you. A lot of kids will add all of this together. That's a big no-no because these are multiplied together. So they got to have the cosine in them. So what you have to do is step by step. We got to move this guy over first. We got to move this guy over second. And then we have to divide by this negative 2 times 13 times 6, right? We have to divide by that. So we have to be super careful in this one. So really, what do I have? I have 17 squared minus 13.85 squared minus 6.2 squared all over negative 2 times 13.85 times 6.2. And I'm going to have to arc cosine that mess. And that should get us our angle B. And so let us see what Virtual Sheila has to show us. So I will arc cosine the fraction 17 squared minus 13.85 squared minus 6.2 squared all over negative 2 times 13.85 times 6.2. And Sheila says it's 109.99. Let's call that 110 degrees. So she says it's 110 degrees. And now I know angle B. I was already given angle A, which means that angle C, the final missing piece, must be 20 degrees. And we now have all our sides. Now let's double check. B was the biggest angle and it had the biggest side. C was definitely the smallest angle and definitely has the smallest side. So I'm feeling super good. And that's your law of cosines. Once you use the law of cosines, use the law of cosines for the entire problem. And it's really only used in two cases, side angle side or side side side. All right, let's ask you a question. All right, let's have a little fun now. You know how to solve all the sides of a triangle. You know how to side all the angles of a triangle. So what about these weird triangles? Could we find the area of these weird triangles? And guess what? Yes, we can. Now that we know how to find everything, there's two simple formulas. One of them is this guy. I like this guy a lot. It's 1/2 AB sine C. That means if I can draw a triangle and I can get two sides and the angle between them, I can find the area. And again, because of my law of sines and law of cosines knowledge, I can always find what I need. I need two sides and the angle between them. So if I memorize that formula, I can do every area triangle problem ever. It doesn't matter about anything else. There's also another one down there at the bottom of the screen called Heron's formula. That formula, is also pretty simple. It's when you have all three sides. So if you'd rather memorize that formula and then find all three sides of the triangle, just like you would any other problem, you could find the area also. So let's just show you how those two area formulas work. They're about as simple as can be. So you draw yourself a triangle, A, B, C. This is 49 degrees, and then I got little c, which is 13, and little b, which is 18. And lo and behold, I have angle, side, angle. Now, if I didn't, I would use law of sines or law of cosines, I guess, in this case, to find out some of the missing information. And then once I have that side, angle, side relationship, then I would just go ahead and use this formula. This formula, plain and simple as you see, area equals 1/2 the two sides multiplied together. So 13 times 18 times sine of the angle between them. And you grab a calculator and you get your area. So here goes my area. 0.5 times 13 times 18 sine of 49. And if I hit enter, the area is 88.3 units squared, whatever those units were that the sides were in. So it was 88.3. Area equals 88.3. And I'm just going to put units squared. I probably should have put units on this problem, but I didn't, so I'm sorry. And there you go. That will work for any side angle side triangle. So once you get side angle side using anything you need to, or if it's given to you, then boom, you got yourself the area. Well, what about this? What if you want to learn a different formula? And that's fine with me too. There's Heron's formula where it says if you add up all the sides and cut it in half, that's your S value, and then you put it under that square root and subtract off all the sides and multiply it all together, you'll also get the area formula. What? Crazy, I know. So be it, right? If you want to learn that formula or use the other one, does not matter. So here I go. Bob wants to sod his backyard, and he's got the sides of his triangle are 9, 12, and 15. So boom, here's Bob's yard. He's got A, he's got B, he's got C. He's got the sides are 9, 12, and 15. So I think this is 9, I think this is 12, and I think this is 15. And notice for the other area formula, I don't have an angle, so I would have to do real quick the lob cosines and find one of those angles, and then I could use that other formula if I didn't want to memorize this one. If you like this one better, that's fine too. So what you do for this one is you cut in half after you add up all the sides. So 9 plus 12 plus 15. So what is that? Half of 27, 36. So it's 18. So we know that our S is 18. Now we go to the formula, and it is 18 times 18 minus 9 times 18 minus 12 times 18 minus 15. And you get 18 times 9 times 6 times 3. And that's what virtual Sheila is for. She will tell me that it is 18. Oh, I forgot to square root it, but I guess I will do that at the end. Times 9 times 6 times 3. I will take that. I will raise it to the half power, and I will get 54 is the area. The area is 54. Now, was this in feet? Yes. Feet squared. Yay. But be careful, though. That's the answer to the area. The question says, how many rolls of 4.5 square foot sod, he goes at Home Depot or Lowe's, whichever you prefer, how many would he have to buy? Well, they're 4.5 square feet each, and I got 54 of them. It looks to me like he's going to need about 12. And so I would tell this guy, go get 12 rolls of sod, and you will be happy. And that's the end. Have a great day. Stay happy, and thanks for being part of this test of flipping. You've done a great job. Give yourselves a hand. All right, now go do some work.